Hello everyone, welcome to Maths with Mr. JN. Today I'm going to show you how to solve this fractional root equation. We will explore different methods of doing it, but I would like to use two methods not to make this video lengthy. First, I will solve it naturally without bringing any application. Then the other one, I will solve it by using different application. So let's start. Solution. Root x plus 1 all over root x minus 1 plus root x minus 1 all over root x plus 1 equal to 10 all over 3. First, we simplify the left hand side. What we do, we look for the LCM of root x minus 1 and root x plus 1. The LCM is multiplying the two, and when we multiply the two, we have root x minus 1 times root x plus 1. Now, we want to simplify. If root x minus 1 goes into the product of root x minus 1 times root x plus 1, it will cancel out, left with root x plus 1. And when we do that, root x plus 1 times the numerator, which is here, then we get root x plus 1 times root x plus 1. Then we retain the positive sign, the operation plus. Then when root x plus 1 goes into root x minus 1 and root x plus 1, it will cancel out this, left with root x minus 1. And when we do that, we have root x minus 1 times root x minus 1. And this gives us 10 all over 3. Now, let's multiply the numerator. We start from here. Root x times root x gives us x. Then root x times 1 gives us plus root x. 1 times root x gives us another plus root x. Then 1 times 1 gives us plus 1 plus, that is the big plus. Then we open the next bracket. We have root s times root s gives us x plus root s times minus 1 gives us minus root x. Then minus 1 times root s gives us minus root x. Minus 1 times minus 1 gives us plus 1. All over, we multiply the denominator. Root s times root s gives us x plus root s times 1 gives us root x. Then minus 1 times root s gives us minus root x. Minus 1 times plus 1 gives us minus 1. All equal to 10 all over 3. Now, let's collect the like terms. We have x, which is this first x. Now we have root s, which we change plus 2 root x plus 1 plus, then here we have x minus root, we change to minus 2 root x, then plus 1 all over x plus root, we cancel minus root x, left with minus 1 equal to 10 all over 3. At the numerator, we have x and x. When we add it up, we have 2x. This 2 root x plus 2 root s minus 2 root s, we cancel out. Then left with 1 plus 1, which will give us plus 2. 1 plus 1 gives us 2 all over x minus 1 equal to 10 all over 3. At this point, we cross multiply. When we cross multiply, 10 we times the denominator of the left hand side, and try we times the numerator of the left hand side. If we do that, we have 10 times x minus 1 equal to 3 times 2x plus 2. When we open the bracket, we have 10x minus 10 equal to 3 times 2 gives us 6x plus 6. Next point, we collect the like terms. Then when we collect the like terms, we have 10x minus 6x. When 6x crosses sign of equality, becomes minus 6x equal to 6. Minus 10 crosses sign of equality becomes plus 10. Then 10 minus 6 gives us 4x equals to 10 plus 6 gives us 16. Now we divide both sides by the coefficient of x, which is 4. When we divide both sides by 4, we have 4x all over 4 equals to 16 all over 4. 4 cancel 4, left with x equals to 4 into 16 gives us 4 as the answer. This is the first method. Then I'm going to use another approach and see if we arrive at the same answer. Let's continue and see if we will arrive at the same answer. Now we continue. I will write down the question, which is root of x plus 1 all over root of x minus 1 plus root of x minus 1 all over root of x plus 1 equal to 10 all over 3. Solution. All we need to do here, we say let's root of x equal to a to make everything look simpler. Then when root of x equal to a, the original equation will be a plus 1 all over a minus 1 plus a minus 1 all over a plus 1 equal to 10 all over 3. We move further, we look for the LCM. LCM is when we multiply the denominator, the two denominators. Then we will have a minus 1 into a plus 1. A minus 1 into the denominator, we cancel out this, left with a plus 1, which we have a plus 1 times the numerator, which is a plus 1, plus, we continue, when a plus 1 into the LCM, it will cancel out, left with a minus 1 times the numerator, which will give us a minus 1 into a minus 1 equal to 10 all over 3. Then the numerator of the left hand side, we have a plus 1 times a plus 1. We can write it to look simpler to be a plus 1 times itself will give us a plus 1 squared, plus we have a minus 1 times a minus 1. We can write it simply to be a minus 1 all squared all over a minus 1 into a plus 1 equal to 10 over 3. Now we want to apply algebraic identity. In algebraic identity, whenever we have, for instance, a minus b into a plus b is equal to difference of two squared, which is a squared minus b squared. And we have another algebraic identity where we have a plus b all squared will give us a squared plus 2ab plus b squared. And we still have another one, the negative one, whenever we have a minus b all squared will give us a squared minus 2ab plus b squared. All this identity, we are going to apply it here. Then let's see how it goes. Now, the numerator is telling us, which is this, a plus 1 all squared is the same thing as this. Then a minus 1 all squared is the same thing as this. Now, if they are the same, we are going to use this operation addition. We are going to add the 2 and see what we get. If that be, we are having a plus b squared plus a minus b squared. If we do that, here we are having a squared plus a squared will give us 2a squared, 2ab plus minus 2ab, 2 of them will cancel out, plus b squared, we have 2b squared. And if we factorize this, we are having finally 2 into a squared plus b squared. So this will represent our numerator. Our numerator will change to 2 into a, remain our a squared, while b is representing 1 plus 1 squared, and 1 squared remain 1. All over, we check the denominator. The denominator here is representing this, and the answer is difference of 2 squares, which is a squared minus b squared. Then if we apply that to the denominator, we are having denominator to be a remain a squared, then b, which represent 1, 1 squared gives us 1, equal to 10 all over 3. Now we proceed. Now we have this, we say cross multiply. If we cross multiply, 10 will times the denominator of the right hand side and 3 will times the numerator of the left hand side. And if we do that, we have 10 times a squared minus 1 equal to 3 times 2 gives us 6 into a squared plus 1. And when we multiply out, we have 10 a squared minus 10 equal to 6a squared plus 6. Now we collect the like terms. Collecting like terms meaning number to one side and the one with alphabet to one side. We retain 10a squared plus 6a squared, crossing sign of equality, it will change to minus 6a squared equal to, we retain 6, which is 6, minus 10 crosses sign of equality to make 6, we change to plus 10. Then 10a squared minus 6a squared will give us 4a squared equal to 16. Now we divide both sides by the coefficient of a squared, which is 4. If we divide both sides by 4, we have 4a squared all over 4 equals to 16 all over 4. 4 we cancel 4, left with a squared equals to 4 into 16 gives us 4. Then to get a, we have to take square root of both sides, which will give us a equal to square root of 4. Square root of 4 gives us equals to 2. But that is not the end. We recall from the beginning of this question where we have let root x equal to a. If that be, we recall root x is equal to a. If that be, we are having root x equal to 2, where a is equal to 2. And that will give us then the next step, we square both sides. If we square both sides, we are having root of x all squared equals to 2 squared. Because we want to remove the square root, the square will cancel square root, left with x equals to 2 squared gives us 4. This answer is the same as the first answer. Now we want to check if our answer is correct. Check. What we do, we write the original equation, which is root of x plus 1 all over root of x minus 1 plus root of x minus 1 all over root of x plus 1 equal to 10 all over 3. Now put x equal to 4. Whenever we see x, we put 4. Then this will change to root of 4 plus 1 all over root of 4 minus 1 plus root of 4 minus 1 all over root of 4 plus 1 equal to 10 all over 3. Root of 4 will give us 2 plus 1 all over 2 minus 1 plus 2 minus 1 all over 2 plus 1 equal to 10 all over 3. Then if we continue, 2 plus 1 gives us 3 all over 2 minus 1 gives us 1 plus 2 minus 1 gives us 1 all over 2 plus 1 gives us 3. Will it give us 10 over 3? Let's go. The LCM is 3. 1 into 3 gives us 3, 9, plus 3 into 3 gives us 1. 1 times 1 gives us 1. Will it give us 10 over 3? Let's see, 9 plus 1 gives us 10 over 3 equals to 10 all over 3. So the left hand side is equals to the right hand side. Our answer is correct. We have explored using two approaches and we arrived at the same answer, and we succeeded checking the answers, and the answer is correct. If this helped, please subscribe, like and share. Thank you.